And in today's video, I'm going to be sharing with you 14 topics you need to master before sitting for chemistry in UTME. So meaning if you can master these 14 topics well, you should be aiming for 90 plus in your chemistry UTME. Hey there, my name is Amaracha. I'm a 200 level DPT student in the Lagos State University with just one JAMB try. If you have short time or you can't finish the syllabus or you don't even know where to start from, keep watching this video. I'll be looking at these topics individually and how you can understand them easily and also the relationship they share with one another. The first topic is compound and mixture. You should know physical and chemical changes, impure and pure substances, and most importantly, separating techniques, characteristics of pure and impure substances, differences between compound and mixture. Another thing you should take note in this sector is conversion of phases, from gas to solid, which is sublimation, from solid to liquid melting, from liquid to solid freezing, stuff like this. They usually come out in the UTME exam. Second is the nature of molecules. This is the fundamental of chemistry. When you understand this topic, most topic in chemistry becomes easier. Here you need to know your types of ion, your cation, your anion. Your cations are positively charged, your anions are negatively charged. Your cations have lost electron while your anion has gained electrons. And also your valency, which is the combining power of elements. You need to also know the elements in the periodic table and their symbols. Even if you don't know everything, try to know the common ones, the one that are usually asked in your past questions, and at least from 1 to 20. Stoichiometry is another part people try to run away from because they think it's hard. It is not hard. It is very easy. You just need to understand the concept. You should know how to calculate empirical formula, relative molecular mass, percentage composition by mass, and also how to write chemical formulas using valency. For example, magnesium chloride, MgCl2. It is written in this form because magnesium has a valency of 2 and chlorine has a valency of 1. So when they exchange their valency, it becomes MgCl2, magnesium chloride. You should also understand your mole concept and learn balancing of chemical equations, because this idea will help in learning qualitative analysis and also electrolysis. The next topic is atomic structure and chemical bonding. Now you need to learn the structure of an atom: pen, proton, electron, and neutron. How your proton is equal to your atomic number, how in a neutral atom your proton is equal to your electron, how isotopy is change in the number of neutrons. You need to know how to draw the shells of an atom, the electronic configuration of an atom, and the rules guiding it. For example, the first shell can only accommodate 2 electrons. And also the discovery of atoms, Rutherford's theory, Plum-Pudding's theory, J.J. Thomson. They usually ask questions on these guys. Under chemical bonding, you need to know your types of bonding: covalent bonding, ionic bonding, dative bonding, metallic bonding, hydrogen bonding, and stuff like that. Next topic is acid, bases, and salts. Learn the characteristics and types of acid, bases, and salts. Your neutralization reaction is also very important. Learn how to find the pH of a solution, your hydrogen ion concentration, your hydroxide concentrations. Questions like this usually come out. And also the uses of indicators and how they change. For example, methyl orange and litmus paper. Types of salt is also very important. For example, your acidic salt. It is acidic because it still has ionizable hydrogen ion and contains acidic properties. And also stuff like water of crystallization and salt hydrolysis. You have properties of salts like efflorescence, hygroscopy. Next is gas laws and kinetic theory of matter. You should learn the basic laws: Boyle's law, their mathematical expression; Charles' law, their relationship between volume and temperature; Dalton's law of partial pressure; Graham's law of diffusion; Avogadro's law; ideal gas equation, and so on. The next topic is periodic table. This is a whole topic on its own that covers a broad aspect of chemistry. You should know what groups and period is on the periodic table. For example, elements on the same group have the same number of valence electrons, and elements on the same period have the same number of electron shells. You should know the general blocks on the periodic table, S, P, D, F, and their general characteristics. You should also take note of your periodic trend. This is a very common aspect that JAMB loves setting questions on: how elements move from left to right, how elements move down the group and across the period. For example, your ionization energy increases across the period and decreases down the group. Your atomic radius, your ionic radius, they decrease across the period and they increase down the group. Stuff like these questions usually come out. And every group also have their general characteristics. You should take note of these characteristics. For example, group 1, they're called the alkali metals. You should take note of their properties. Group 2, alkali earth metals. Group 3, the boron family. You should take note of the properties of this group and this period. You should also take note of stuff like, the highest electronegative element, how to know which element is more electronegative than the other. For example, fluorine is the most electronegative element in the periodic table. You might be asked to compare between fluorine, oxygen, chlorine, or you might be asked to do this in either ascending order or descending order. You know that electronegativity increases across the period and electronegativity reactivity decreases down you. So this trend is going to help you to solve questions like this. The next topic is qualitative and quantitative analysis. Quantitative analysis is like a continuation of stoichiometry. This aspect deals with numbers and measurements in chemistry. In qualitative analysis, you learn about the properties of elements in a reaction. For example, an element reacts vigorously with cold water to produce hydrogen gas and a colorless solution. The element is most likely sodium. Next topic is water, air pollution, and water pollution. Under air pollution, take note of common pollutants like carbon monoxide, sulfur dioxide, and their characteristics, their sources, and their effects. For example, acidic rain. Under water pollution, read in the same pattern too. Their sources, their effects, and their control measure. Then for water as a topic, you can consider solution solubility, differences between true solutions and colloidal solutions. Please ensure you know calculations of solubility to understand the solubility curve, the conditions that affect the solubility of a substance, for example, temperature and pressure, and how they affect it. You can also be asked questions on water hardness, their causes, and how they are removed. Another important topic is oxidation and reduction. This topic always comes out. You should learn the definition of oxidation and reduction regarding the addition of oxygen, removal of oxygen, adding of electropositive or electronegative elements. You should also learn how to calculate the oxidation state of elements in a compound. Also learn how to identify your oxidizing or reducing agents. Next topic is electrolysis. Your understanding on oxidation and reduction is really going to help you understand this topic very well. Learn the concept of Faraday's law of electrolysis. You must understand these laws and their applications. Learn your ionic theory, your electrodes, your electrolyte, different types of electrolytes. And please learn the process of electrical discharge using the electrochemical series. Take for example, you have chlorine and zinc, and they are asking which is likely to discharge first. When you know the rules guiding the preferential discharge of ions, questions like this becomes easy for you. The next topic is non-metals. You should know the general properties of these guys, their unique properties. JAMB loves asking questions on the uses and preparation of these non-metals. They focus more on elements like oxygen, sulfur, nitrogen, and carbon. Carbon is very important. Please take note of the allotropes of carbon, diamond, graphite, and even the fullerenes. And also the oxides of non-metals, their physical and chemical properties. The next topic is metals and alloys. Learn the general properties of metals, different types of metal, and also the sources from which they are derived from. Learn your alloys in metal, most importantly steel, bronze, brass, etc. Reduction of metallic oxides using carbon or electrolysis. Lastly, organic chemistry. This is a very broad topic. Please learn your hydrocarbons. Over the years of past questions, if you are very observant, you would know that JAMB love asking questions on what I'm about to share with you now. Functional group, homologous series, isomers. If you're not going to be learning everything, make sure you know these ones. You are alkene, you are alkene, you are alkyne, alkanol, alkanal, carboxylic acid, the ketone, esters, and ethers. Please learn your IUPAC nomenclature and the rules that are guiding them. Make sure you know the general formulas of your homologous series. For example, alkene is CnH2n plus 2. Take note of reactions like esterification, saponification. These are also very crucial. And also differences between saturated and unsaturated compounds. If you can cover these, then you have a strong ground in your organic chemistry. This is everything, guys. You can also decide you want to read all the topics in your JAMB syllabus. But before doing that, make sure that you have mastered these ones. If you also want me to continue this series for subjects like biology, physics, and English, let me know in the comment section. Subscribe to my YouTube channel now so you don't miss out on anything. Bye, guys.